Okay, so today we are covering primarily section 8.1, working with the Cartesian coordinate system. And essentially the Cartesian coordinate system, it's kind of a fancier way of just saying we're going to be working with graphing, our introduction to this particular way of setting up and working with graphing. And I say this mainly from the standpoint of we have different coordinate systems that we use in different levels and different modalities with math. So for instance, we have the Cartesian coordinate system. This is the most common one that we're going to be working with and the only one we're going to be seeing for this quarter. But we do also have ones like the spherical coordinate system, I believe it's not hyperbolic. We have one or two other, I'm forgetting the exact name of them, spherical, and there's another one, a couple of them. But essentially, it's different ways that we can set up and graph equations or graph problems or graph scenarios that we are working with in the context of our problem that we have. So our Cartesian coordinate system, that's the main one that we're going to use. That's all that we're going to focus on for today and for this quarter. So our preliminary stuff that we want to go through, again, we're going to work with our vocabulary and definitions of these things. So the Cartesian coordinate system normally set up two axes, a horizontal and a vertical one. So we have a straight vertical axis, a straight horizontal axis. Generally speaking, the horizontal axis denotes the x-axis, and the vertical generally denoted as the y-axis. Now, I will make a note of this because this is something that I know we aren't going to be having as much of this potentially on the, I think it's going to be as easy to do on the homework compared to if we had this more of an in-class one. You want to absolutely make sure that you are labeling your x and y axis or your horizontal and vertical axes accordingly. And I say this primarily due to the fact that while we generally denote these axes as x and y, we can and we absolutely will in future classes see these denoted with different variables. Maybe t, maybe h, maybe a, maybe n, etc., etc. So I highly recommend if you are building these graphs for yourself, you get in the habit of labeling them. What does each of the axes mean? Right from the beginning. It's a small little bit of organization, but it goes a very, very, very long way with these types of problems. And I think the part that trips people up with graphing a lot of the time is they don't do this labeling step for themselves. And then the rest of this all falls apart because they don't know where they are looking on the graph and what they should be graphing from as they reference these things. So our next definition that we have is of an ordered pair. So the ordered construct, in parentheses, x comma y, where x and y are numbers, is called an ordered pair of numbers. So each part corresponds to a value on that respective axis. So again, this is where denoting which is your x-axis, which is your y-axis absolutely matters. And again, if you're thinking, well, okay, you said before that it generally denotes this, and yes, it does. However, think beyond the scope of just this course where you're going to use primarily x and y. Again, you are going to see multiple different variables showing up, and we want to get used to recognizing which variable or which number goes with which variable, and then which axis does this denote in the graph itself. It should also be noted that with an ordered pair, the way that we order numbers in an ordered pair absolutely matters. I cannot emphasize this enough. A lot of people will just plug in, well, I'll put a 3 in for that spot, and I guess I'll put a 5 in over there, and maybe I can swap them back and forth. Can't do that. The ordering absolutely matters. And a lot of people just rush this part of their process if they're asked what is the ordered pair of a point, for instance. And people will just put a number here, put a number there just because. Again, all of these correspond to one another. What number you plug in here corresponds to the x or the y-axis. Which one is the x or y-axis is based on how you label the horizontal and vertical axes. So it all stems together here. And our last one that we have are our definitions and vocabulary. The very center of the graph, this is where the two lines that we have, that vertical and horizontal, meet together. The center of the graph is referred to as the origin and is always the point 0, 0. And this is one that's very unique in the sense of it doesn't matter which one you have labeled to be x, which one you've labeled to be y. That point where the two lines cross each other at the very, very middle of the graph is always going to be the ordered pair 0, 0. That will never change. Okay. So setting up and plotting some points. We'll go through some examples with this down here as well. I'm not going to promise how good it's going to look graphing on a computer versus a piece of paper and overhead, but we'll do what we can with it. So when you are creating a graph, these are the requirements that you want to make sure you have written down for yourself. If you don't have this on your graph, I see a lot of people lose a lot of points in graphing things because they haven't done all of these. And it might look like, okay, well, that's 4 things I need to do for every single graph that I'm making. It really isn't a whole lot. And I'll show you guys kind of the bare bones, minimalist way that you can get all of these graphs together or set up for yourself. So when you're making a graph, set up your axes. Which one is horizontal? Which one is vertical? Label them. Which one is your x-axis? Which one is your y-axis? Or if you're working with different variables, which again, you will be seeing in later chapters and later classes, all of that. Which one is t? Which one is h? Which one is m? Which one is n? Etc., etc. Label your axes with variables. Define which direction is positive and negative on your axes. It is amazing to me how many people will put both directions of a graph to be positive or both directions are negative. And it doesn't work that way. So define which way is positive, define which way is negative. And then last but not least, scale those axes accordingly. So let's say you want to do every single tick mark, again, if you're using graph paper, which I would recommend you use for these, is every single little tick on the graph going to be going by 1s? Is it going by 5s? Is it going by 10s? Something to that effect. So scale each axis accordingly. And again, I will be showing you guys how to set this up. It's a quick, 30-second process to get it up and running if you want to do a kind of a minimalist setup for your graph, which I'm fine with. I believe most of your instructors in the future would be fine with that as well. But if you get these nailed down for yourself, oh man, graphing is so much easier that way. So the other part, again, that goes along with a lot of this graphing, make sure that your axes and your labeling and your setup for all of this is as neat as possible. The more that you have to guess at what you've written, the harder this thing is going to be. And we don't want things to be that much harder for ourselves if we don't have to make it that way. So when we have done all of this setup, when we are plotting a point, we're going to start at the origin and move the corresponding number of places based on the ordered pair's numbers and their signs. So we're always starting the origin. We're saying, okay, am I going positive or negative along the x-axis, and by how much? Am I going positive or negative along the y-axis, and by how much? We just count those out. Once we have counted both in the x and the y direction, or however we have it labeled, we plot the point on the graph, and bam, we are done. Okay. So we're going to work with these 4 examples for setting up and plotting points. So again, this is the step-by-step process that we're going through as we have it here. But let's say we didn't have these written out for ourselves, and we're going through and plotting this for the very first time. So again, I'm going to jump us over to our whiteboard, and fingers crossed that this goes through and goes as well as I'm hoping it will, at least for the graphing of these things. So we'll jump over to the whiteboard. Got this here. Okay, so first and foremost, we're plotting 4 points. Now our step-by-step process for creating a graph, and again, I would highly recommend that you do this for yourself. as you are setting up graphs for this class and all of your future ones. I will also note that if/when graphing is showing up on the test that will encompass this, it's going to be test 4. We've got some time between now and then. I would highly recommend, if you are having some issues uploading or answering a graphing question or graphing something on WAMAP, you write this out for yourself and you submit that to me for partial credit, which I will take a look at if you do send those in. So let's say we're plotting a couple points here. So our first point that we had was 2, 4. We're going to set this thing up for ourselves. Now, I highly recommend to everyone use graph paper for this. It makes it a heck of a lot easier to graph these things because we've got a grid. Half of our work is kind of done for us at that point in time. So I'm going to set my origin to be about right there. That looks reasonable enough. So I'm going to set up my horizontal axis. Vertical there. Again, I might be taking a bit longer on doing this compared to if you guys are going through and writing this out for yourselves, because I'm trying to stay along here and work against technology a little bit as I'm going through this. So I've set up my set of axes, my 2 sets of axes there. Okay. I have my horizontal and my vertical. And I'll note to you guys as well, a lot of people have the issue of, I think let's say issue, I think it's a very reasonable concern of, do the lines have to be perfectly accurate and straight and everything like that? And you want it to be as straight as possible, but I'm not going to be that nitpicky about it. Put some extra time and care into it, and it should be good enough. So we've set up our axes. We're going to label our axes. So I'm going to have my horizontal one be X, vertical is Y. And there you go, you've just labeled your axes. Define the positive and negative directions on each of those sets of axes. So, okay, I'm just going to put, for the horizontal, there's the positive direction, there's the negative direction. For the y-axis, or vertical axis that we have here, there's the positive direction, and there's the negative direction. So, got the axes set up, we've got them labeled, we've got the directions, and now we need to scale them accordingly. Am I going by 1s, by 5s, by 10s, something like that? Now, if we're looking at these, that's checking to see if I'm counting these parts over. Am I going by 1s, 5s, 10s, etc., etc.? So those are the references that we're using for these. Now, if you are someone who would like to go through and label each one of these little tick marks that we have along a set of axes, you are welcome to do so. I am not requiring that you do that. You can use a little bit of a shortcut for yourself, and I'm fine with this. I am going to label and go by 1s for each of these. So I'm not going to label each and every point on here. Instead, I'm going to go over about 5 or so, and then I'll label that one. So moving from the origin, so our center part, I'm going to go over 1, 2, 3, 4, 5. Just put a little 5 down there. And then go 6, 7, 8, 9, 10. So I've labeled and I've determined that my horizontal axis is going to go by 1s, which is fine. And then I'm going to go in the opposite direction, negative 1, 2, 3, 4, 5, 6, 7, 8. So something like that, that is all that for me I would need to see to know, okay, you've labeled the horizontal axis by 1s. Good to go. And again, if you would like to label it as 1, 2, 3, 4, everything like that along the way, you're welcome to do that, but that is not required. As long as you have some kind of scaling like this, again, this is kind of the minimalist way of setting this thing up, I'm happy with this. You do the same thing vertically. So again, counting from the origin, going up 1, 2, 3, 4, 5. Make sure you're counting properly. I can't tell you how many times I've seen people, and myself included, count incorrectly on those. And 6, 7, 8, 9. So I'm going with my vertical axis by 1s also, which is fine. So doing that there. Now I've also gotten the one from people saying, all right, well, you said to label the positive and negative directions on these axes, but we already have it labeled that this direction is negative, this direction is negative based on how we have the scaling set up. So do I need to include this negative out front, this negative off the side here? And if you're going to label the axes this way, then you don't necessarily need to do that. I find it helpful for me specifically to know and clearly define that at the very beginning. And then for me personally, I kind of forget to get rid of that every now and then. But as long as you have it labeled with either the numbers or that general positive and negative sign out to the side, I'm happy with whichever way you want to do that. As long as it's very clear which direction is positive and which direction is negative on each set of axes. Okay. So may have seemed like, okay, there's a whole lot that's going on there. That took a long time to get that set up. And that's, again, I'm going through and giving you guys a lot of explanation or a lot of clarification as best I can on what I'm looking for. So this setup that you're looking at right here on screen, this is the minimalist way of setting up a graph for yourself before you plot any points or anything like that. And I'm perfectly happy with this. Something like this is A-okay. But you absolutely need to have all of these components if you are setting up and graphing anything. If you don't have this, you're going to lose points. Because again, I've seen people not label the axes. I've seen people not scale the axes. I've seen both directions labeled as positive or both directions labeled as negative, and then everything goes wrong from there. So we don't want that to happen. All right. So getting back to our main part that we're doing with this, we are plotting the points. We have starting with our point 2, 4. We have 3 others after that, but we'll get to those here in a second. So I'm going to do 2, 4 in blue. So our process for doing this, we are starting at the origin. Our x value is 2, our y value is 4. So from the origin, and you don't need to do this every single time, I'm just going to do this a couple of our earlier examples. So starting from the origin, I'm going to be counting over 2 in the positive x direction, because my x value is positive and it's 2. And then I'm going from there, I'm going to be going 4 in the positive y direction. So I'm going up to here. And I have the point 2, 4. So I've just plotted that point and I'm good to go there. I'm going to do a little bit of labeling here just so we keep being organized. Better 2 and 4. There we go. So that's our first point that we've plotted. And again, I'm dotting these things as we're going through them just to illustrate where we're going or how we're getting to there. On the test or the homework, you do not need to do that. I just need to see the point at its end result. So the point -1, 2, that's the next one that we're working with. I'm going to work with that in red. So we're tracking these things. So once again, I'm starting from the origin. And I'm going to count, looking at my x value first, I'm going to count 1 in the negative direction. And then I'm counting 2 in the positive y direction. So I'm going up right to there. And that's my next point, -1, 2. Our next point that we have is -3, -5. And we'll do this one in green. So once again, starting from the origin, looking to my x value, my first number that I've been given, I'm going 3 in the negative direction. So I'm counting over 3. And then I'm going 5 in the negative direction for my y values along my x or my y axis. It's going to put me right to here. value here is -3, -5. So we'll take a look at, how many other colors do I have that I can work with? Oh, we have a couple others. Let's use, we'll use yellow for another one here. So our last point that we're working with is 5, 0. We'll do this one in, this is, yeah, it's yellow. So I'm starting from the origin yet again. I'm looking at my first part of this ordered pair, and it's a 5. So I'm going 5 in the positive direction along the x-axis. So I'm counting over 5. And then I'm looking at a y value, or the y value we have there of 0, which means I am not going to move vertically at all. So I'm only moving horizontally, and I'm at the point 5, 0. Okay. So we've just plotted all 4 of these points. So as you're reading these, again, these ordered pairs, you're going left to right. What's the x value tell me? The ordered pair. That tells me how much I'm moving in the positive or negative direction along the x-axis. Then you look to the y value. That tells you how much you're moving in the positive or negative direction along the y-axis. Once you've followed both of those, that tells you your end point. Plot the point there, and you're done. Now again, with these examples that I have, I've listed out these little pathways of how we got to them in this regard, just highlighting these as we're going through them. When you are going through and plotting these for yourself, you do not need to show those dotted lines of how you got there. I think they're really helpful to see the process of how we're thinking about it, but I'm not going to require that you have those dots mixed in there or written in there for yourself as you're going through those. I just need to see the endpoints written in there. Okay. So our next part that we have, because that is how we are graphing points on the Cartesian coordinate system. That's if we're doing it for just plotting things, like here's some points, plot those. If we are given an equation and we find points and we need to plot those, this is the exact same process we're doing for all of those. So the variation beyond this, there isn't a whole lot of it. Okay. Now we're going to move on to the next part that we have here, which is having us identifying coordinates of an ordered pair. So this example, these set of examples that we did, we set up a set of graphs and we plotted them. Now we're going to be doing almost the exact opposite. We've been given a graph, we're going to have been given some points, and we need to determine what each of those points are on the graph. So I'm going to go off to the side here. I'm going to set up an example with these. Again, I don't have anything explicitly written out on the notes, mostly because it's not as easy to get graphs shown up or typed up and looking good in Word. But we're going to go through some examples here with this. So again, I'm going to set up a graph, and I'll give you guys a little bit of time to go through and figure out for yourselves what these are going to be when I set this up for yourselves. Okay. And we're going. I don't like this graph as much, this vertical as much. A little bit neater. There we go. And you guys are probably seeing a little bit of a perfectionist in me that's coming out at this point in time. 5. Negative 8's down here. There we go. So there we go. There is the initial axes and graph setup. So I'm going to give you guys, I'm going to put some points in here. I'm just going to label the points A, B, C, and D. Okay. And I'm going to give you guys about a minute or so to go through and on your own, think on it for yourself. What is the ordered pair at each of these points? Meaning, what is the X and Y value? And then if you have paper nearby or something to keep track of what your thoughts are with those, we'll go through and I'll tell you guys here's what each of these points are going to be. So I'm going to do these in different colors just for the sake of differentiating them. And then we'll go from there. So let's say we have point A, B, say C, D, whoops, better D, there we go. And we'll throw one more in there just for good measure. E. Okay, so we have 5 points here. I'll move this just a little bit over. Hopefully that's a bit centered now. So all I'm looking for, and we'll go through this here on our own, or all together here in a second, but I'm just looking for you guys to gain an opportunity. Again, write down for yourselves and something that you have nearby. What is the ordered pair? So again, that X and Y value at each of these 5 points. And then I'll give you guys a minute or so to go through that on your own. And then we'll go through and we'll find the answers for these all together. So I'll give you guys a minute or so here. I'll mute myself. That will you guys take a minute for that, and we'll go through this together here in a second. Give you guys another about 30 seconds or so. Okay, so we'll go through these and we'll identify the ordered pairs for A, B, C, D, and E. So looking at our A value, or point A here. So again, we're going from our origin, seeing how far are we moving horizontally in our x direction. So I'm moving over 5 in the negative x direction, which means I have an x value of -5. And then I'm moving up by 1, 2, 3. So I have a y value of 3. So the point A is the ordered pair 5, 3. It's a bit better here. Looking at our B value, again, we're going from the origin, counting over 2 in the positive x direction. So my B value has an x value, right? Point B has an x value of 2. And then I'm going down by, looks like 7, -7. Yeah. Going 7 in the negative y direction, which means I have a y value of -7 there. Looking at point C, again from the origin, I'm going 3 in the positive x direction, so my x value is 3. I'm going up 1 in the y direction, so I have a y value of 1. So at point C is the ordered pair 3, 1. Looking at D, I'm not moving horizontally. I'm not moving left or right at all for this thing, which means my x value, if I'm not moving anywhere, my mathematical equivalent of nothing is going to be 0. And then I'm moving up by 7. So my y value is going to be 7. So point D is the ordered pair 0, 7. And then last but not least, we're looking at E. So looking horizontally, again, starting from the origin, I'm moving 10 in the negative direction for my x value. So my x value is a -10. And then vertically, I'm moving down, is that 4 units? Looks like 4, yeah. I'm moving down 4, so my y value is going to be -4. And so hopefully we got these correct as we were going through them. Again, if we didn't, that's fine. This is the learning process. That's why we're going through some examples and getting some of the kinks worked out of the way now. But these are the answers that we should be getting to determining the ordered pairs of each of these points. Now, I will make a note of this as well, because I've seen people ask questions about this. It's a very understandable one. I think it shows up a little bit on WAMAP as well. But if you are asked to give an ordered pair as an answer, you absolutely must put your answer inside of parentheses with a comma between the two x and y values. If you do not do that, WAMAP is going to ding you on points. It's not going to give you credit for it. So for example, for point C, if you just put your answer and you type it in just like this, just as 3, 1, it will probably tell you that you have the wrong answer. Because we have the question of, well, am I listing numbers out? Am I working with a some other kind of problem? It's unclear at that point in time. So make sure you are always, always, always putting an ordered pair inside of parentheses. If you do not do that, again, you're going to lose points. You don't want that to happen. All of your future classes, your future graphing that you're going to be doing, you're going to want to have everything written inside of parentheses. All ordered pairs, all points, all of them are written that way at all times. No exceptions. Okay. So just want to make that last part abundantly clear, because it's a very understandable question to say, can I do that? Can we avoid not doing that if we don't want to? You absolutely must always do that if you are asked about an ordered pair. No exceptions. Again, that's again beyond the scope of just Math 70. It's in 72, 97, pre-calculus, calculus, differential equations. When I was working with graphing up in, what was one? Differential equations, systems of differential equations, so 3, 4, 500 level math classes, you're working with all of those inside of parentheses as well. So this is not going away. So this is this bulk of the material that we had and we have for 8.1. Again, a lot of it's just setting up our graphs. And again, these are the two quick and easy examples that I have for the minimum requirements I'm looking for if you're setting up a graph for yourself. You don't need to do a whole lot else beyond that. Some people have also asked, well, do I need to have the x-axis always go between -10 and 10, kind of like how you have it written out? And no, you don't really have to. If you know your points are kind of smaller, you can go by maybe -5 to 5, -5 to 5 on the x and y axes. I think having at least a 5 by 5 graph is a pretty good solid base frame if you're looking for something to start with. And then expand each of the axes if you need to based on what you're graphing. But again, minimum requirements that I'm looking for if you are going to be graphing something and setting up a graph for yourself. These are the minimum requirements that your other future instructors are going to be looking for as well. So make sure you label the axes, you scale the axes, determine which direction is positive and negative, and try and keep it as organized as you possibly can. And again, a lot of people lose a lot of points on tests because they don't do that. And there's some really funky things you can do with graphs if you don't label them, or depending on how you do or don't want to label them, that can still make them correct, but have them look really weird. So be very, very explicitly clear how you are setting these things up. And I'm going to go back to that, our notes really quick. Here is your guide. These are the requirements that you're looking to have every single time you create a graph for yourself. No exceptions. Okay, so that is everything that we have for today. You have an introduction to graphing with this. And we're going to end things there for today, and I'll take any questions that you guys have over any of the material, and we'll go from there.